Here in problem 10, it's requested to find the area of the region bounded by the shown graphs. Actually, we have here different ideas. Maybe here we have one curve and interval. Maybe here we have two curves. Maybe here we have three curves, like this one. So in general, sketch the region. From sketching the region, you will be able to know which is the upper curve, which is the lower curve. While sketching the region, take care of the intersection points. Step 3, now you know what is the upper curve, what is the lower curve, you know where are the intersections, so set up your integral. And finally, evaluate the integral. Evaluate the integral. In problem 1, find the area of the region bounded by the graphs y equals to 3x squared minus 3 and x-axis on the interval from 0 to 3, starting by finding the interval from 0 to 1. Okay, so we need first to sketch. 3x squared minus 3 is a parabola shifted down 3 steps. Y equals to 3x squared minus 3. Here, this is y equal to 0. We need to find the area of the region from this curve to the x-axis. We need to find the area of this region. Okay, here the upper curve is y equal to 0. Here the lower curve is y equals to 3x squared minus 3. 3x squared minus 3. Okay, now we need to find the intersection point, this intersection point. This intersection point is the intersection between the curve and y equal to 0, between the curve and the x-axis. Okay, so 3x squared minus 3 equal to 0, which means that in 3x squared equals to 3, that leads to that in the x squared equals to 1. Find the root for both sides, so x equals 2 plus or minus 1. But we are interested in the positive sign. So the area now will be integration from x equal to 0 to x equal 1. The upper curve is 0. The lower curve is 3x squared minus 3 dx. Now evaluate the integral. Negative, factor it out. Integration of 3x squared is 3x power 3 divided by 3 minus 3x with the limits from 0 to 1. Cancel 3 with 3. So this will be negative, replace x by 1, you will get 1 minus 3. Minus, replace x by 0, you will get 0. So this is 2 at the end. What if it's requested to find the area between y equals to 3x squared minus 3 and x-axis on the interval from 0 to 3? Okay, by sketching this region, 3x squared minus 3, and knowing where will be the intersection points, this means that in here, the area from 0 to 1, here is the area from x equals 0 to x equal 1, and here is the area from 1 to 3. Here x equals to 3. So this switch curve. Then now we have two regions. So the area now will be sum of these two areas. This is the first one, and here is the second one. Okay, regarding the first part, here we have y equals to 3x squared minus 3. This is the lower curve, and y equals 0. This is the upper curve. Regarding the second part, y equals 0. This is the lower curve, and y equals to 3x squared minus 3. This is the upper curve. So the area now will be integration for finding the area of the first part. Integration, the intersection point here is 1 at x equals to 1. The integration from 0 to 1. The upper curve is y equal to 0 minus the lower curve is 3x squared minus 3 dx plus integration for finding the area of the second part. Integration here will be from 1 to 3. From 1 to 3. The upper curve here will be 3x squared minus 3. The lower curve is 0, dx. Then evaluate the integration. Already we found the integration from the first problem, it was 2. So it's 2. This integral, the value of this integral is 2. So it's 2. Plus integration For 3x squared minus 3 from 1 to 3, it will be the integral as it is, x power 3 minus 3x with the limits from 1 to 3. From 1 to 3. This equals to 2 plus. Substitute with 3. 3 to the power 3 is 27 minus 9. This is the substitution with the upper limit. Minus substitution with the lower limit, 1. It's 1 minus 3. So it will be 22 at the end. This is for the first problem. For the second problem, B, the last one was A. B, here find the area of y equals to e to the power x minus 4 and x-axis on the interval from -2 to 1. X-axis is y equal to 0. So sketch this region. Y equals to e to the power x minus 4 is this curve. Here the intersection point is at y equal to 0. So e to the power x minus 4 equal to 0 means that in e to the power x equals to 4, which means that in x equals to lim 4. Lim 4, which is 1 point some value. So we can stop here for 1. And here 4x equals to -2. Then this is the requested region. Here this is y equals 0. Here y equals to e to the power x minus 4. So the area will be integration of the upper curve minus integration of the lower curve. Integration of 0 minus e to the power x minus 4 dx. With the limits from x equals to -2 to x equals to 1. Integration from -2 to 1. Now the integral will be, factor this negative out, integration of e to the power x, it's e to the power x, minus the integration of 4 is 4x, with the limits from -2 to 1. Substitute with the upper minus substitute with the lower. To simplify the computations, it's 4x minus e to the power x, with the limits from -2 to 1. Substitute with the upper, which is 1. So this will be 4 minus e to the power 1, minus substitute with the lower, replace x by -2, this -8, minus e to the power -2. Okay, another problem, if we have one function and limits. See, we have here y equals to e to the power 2x, y equals 0, x equals 0, and x equals to ln 3. Sketch y equals to e to the power x, y equals 0, here is y equals 0, x equals 0, this x equals 0, and here x equals to ln 3. It's requested to find the area of this region. Here the upper curve is y equals to e to the power 2x. The lower curve is y equal to 0. Here this x equal to 0. Here x equals to ln 3. Okay, so the area now will be integration of the upper minus the lower. Already the upper curve is e to the power 2x. Integration of the lower curve is 0, dx. Integration is running from x equals 0 to x equals to ln 3. So this will e to the power 2x divided by 2, with the limits from 0 to ln 3. Substitute with the upper minus substitute with the lower. Half out, it's e to the power 2 ln 3 minus e to the power 0. In e, find the area bounded by the curves y equals to 2 to the power x, exponential functions, y equals to 1 minus x, and x equals to 1. To sketch this region, y equals 2 to the power x, and take care that in already here we have intersection at y-axis at x equals 0, y equals to 1. Now going to sketch y equals to 1 minus x. At x equals 0, y equals to 1, the same intersection point, and at y equals 0, x equals to 1. And at the end, x equals to 1. So here we have y equals 2 to the power x. Here we have y equals to 1 minus x. And here we have x equals to 1. So the upper curve here is 2 to the power x. This is the upper curve. The lower curve is 1 minus x. So the integral will be, area will be integration from the minimum x, which is 0, the maximum x is 1, The upper curve is 2 to the power x minus the lower curve is 1 minus x dx. 2 to the power x, its integral is, it's 2 to the power x divided by ln 2 minus the integration of 1 is x. The integration of x is x squared divided 2 with the limits from 0 to 1. Substitute with the upper, it would be replace each x by 1. It's 2 divided by ln 2 minus, replace x by 1, 1 minus half, minus substitute with the lower, replace x by 0. 2 to the power 0, it's 1 divided by ln 2 minus 0. Here find the area of the region bounded by the two curves, y equals to x squared minus 18 and y equals to x minus 6. Y equals to x squared minus 18, this is a parabola, shifted down 18 steps. Y equals to x minus 6, it's a straight line like this one. Okay, so this straight line intersects at here at x equals to 6, y equals to 0. Regarding the intersections of the parabola with the x-axis, this 3 root 2 and 0. Here, this negative 3 root 2 and 0. Regarding the intersection point between the parabola and y equals to x minus 6, we need to know by equating the curve and the line. X squared minus 18, this equals to x minus 6. So x squared minus x minus 12 equal to 0. The solution for this equation would be x equal 4, x equals to negative 3, x equals to 4, and x equals to negative 3. Here, these are the intersection points. At x equals to 4, y equals to negative 2. At x equals to negative 3, y equals to negative 9. The upper curve is the line y equals to x minus 6. The lower curve is the parabola y equals to x squared minus 18. Here is the in-between area. So the area now would be integration from negative 3 to 4. The upper curve is x minus 6. The lower curve is x squared minus 18 dx. Simplify the integrand. It's integral from negative 3 to 4 x minus x squared negative 6 plus 18 is plus 12 dx. This equals to integration from negative 3 to 4. This equals to integration of x is x squared divided 2 minus integration of x squared is x power 3 divided 3 plus 12x with the limits from negative 3 to 4. Substitute with the upper minus substitute with the lower. This equals to substitution with the upper, 16 divided 2 minus 64 divided 3 plus 12 times 4 is 48 minus substitute with the lower, which is negative 3, this 9 divided 2 plus 27 divided 3 minus 36. In problem F, find the area bounded by the regions x plus y equals to 3 and y plus x squared equals to 3. We need to sketch. Here we have y equals to 3 minus x squared, and sketch x plus y equals to 3 and y equals to 3 minus x the same. So y equals to 3 minus x squared. The intersection of this parabola with the x-axis here at x equals 0, y equals to 3. Here at y equals 0, x equals to root 3. It's root 3, 0, negative root 3, 0. Okay, so at x, disregarding the parabola, now regarding this line, y equals to 3 minus x. At x equals 0, y equals to 3. At y equals 0, x equals to 3. So we expect the line in this form. So we need to find the area of this region. The intersection points at x equals 0, y 3. And here we need to find the value, the coordinate of this intersection point. Solve both equations together. 3 minus x equals to 3 minus x squared. So this means that in here, x squared minus x equal to 0. Factor x is x minus 1 equal to 0. So this means that in x equal to 0 or x equals to 1, the coordinate of this point is at x equal 1, y equals 2. So now the area would be integration from 0 to 1, the upper curve, which is 3 minus x squared, minus the lower curve, which is 3 minus x dx. So the integral now will be integration from 0 to 1. 3 will be cancelled with 3. It's negative x squared plus x dx. This equals to, what's the integration of x squared? It's negative x power 3 divided 3 plus the integration of x is x squared divided 2 with the limits from 0 to 1. Substitute with the upper minus substitute with the lower. This negative 1 over 3 plus 1 over 2, which is 1 over 6. In problem G, found the area bounded by the curves y equals to 1 over x squared, y equals to negative x squared, and the two boundaries x equals 1 and x equals 2, xy plane. 1 over x squared, it's like this one, negative x squared with the limits from x equals to 1 to x equals to 2. So we're talking about this region. Here x equals to 1, x equals 2, here y equals to 1 over x squared, here y equals to negative x squared. So the area here will be integration from 1 to 2. The upper curve, which is 1 over x squared, minus the lower curve, negative x squared dx. Okay, to be able to evaluate the integral of the first term, it's 1 over 2 reformulated to be x to the power negative 2 plus x squared dx. Raise the power by 1 divided by the new power. This equals to x to the power negative 1 divided negative 1 plus x to the power 3 divided 3. The limits from 1 to 2. Substitute with the upper minus substitute with the lower. This negative 1 over 2 plus 8 over 3. This for the substitution with the upper limit minus it's negative 1 plus 1 over 3. This for the substitution with the lower limit. And then the final answer. In problem H, we have the two curves x equals to negative 3y squared plus 4 and x equals to y power 3. Sketch the two curves. X equals to negative 3y squared plus 4, negative 3y squared plus 4 like this. It's x as a function of y, it's not y as a function of x. So it's like this. X equals to y power 3, it's like this curve. So we need to find the area of this region. So it's proper to think here, not the upper and the lower curve, but the right and left curves. Here, where is the right curve? The right curve is x equals to negative 3y squared plus 4. The left curve is x equals to y power 3. Okay, so the area here will be integration of the right minus the left. It's corresponding to integration of the upper minus the lower. Integration of the right minus the left. It's the right curve, which is negative 3y squared plus 4 minus the left, which is y power 3 dy. We need to know the intersection points. How can we find the intersection points between these two curves? It's y power 3 equals to negative 3y squared plus 4. Using the calculator, so we get the roots. Y equals to negative 2 and y equals to 1. So this means that the integration here is running from negative 2 to 1. Now, the area will be negative 3y squared is negative 3y power 3 divided 3 plus 4y minus y power 4 divided 4. The limits from negative 2 to 1. The upper minus the lower. Substitute with the upper minus substitute with the lower. This equals to. I think it's clear that we can cancel 3 and 3. It's negative 1 plus 4 minus 1 over 4. It's for the substitution with the upper. Minus the substitution with the lower. It's negative 8. Sorry. Negative 8. Negative 8 minus 8 minus negative 2 to the power 4, which is 16 divided 4. Then you can compute the final answer. I find the area between the curves. Here we have y equals to x squared, y equals 2 minus x, and y equals 2 plus x. Y equal x squared. This y equal x squared. Y equal 2 minus x. This for y equal 2 minus x. Y equal 2 plus x. This for y equal 2 plus x. X axis, y axis. We need to find the intersection points. The intersection point between the parabola and y equals to 2 minus x. The intersection point between the parabola and y equals 2 plus x. So here x squared equals to 2 minus x, or x squared plus x minus 2 equal to 0. It's x plus 2 times x minus 1 equal to 0. So we get here in x equals to 1, the proper intersection, as we are in the positive side. The same here, if we have x squared equals to 2 plus x. Or in other form, it's x squared minus x minus 2 equal to 0. X minus 2 times x plus 1 equal to 0. So it's proper here to say that in x equals to negative 1, as we are in the negative side. X equals to negative 1 to 1. But the upper curve here is different from the upper curve here. Here the upper curve is 2 minus x. Y equals to 2 minus x. The upper curve here is y equals 2 plus x. So the area will be sum of two areas. This equals to, for the first part of the area, the first part of the area is integration from 0 to 1. The upper curve, which is 2 minus x, minus the lower curve is x squared dx. The lower curve in both areas is y equals to x squared. Here the same, y equals to x squared. Okay, and evaluate this area. Plus integration, the second area is this one. This is the second area. Integration from negative 1 to 0. The upper curve is 2 plus x minus x squared dx. I think it's easy to evaluate both integrals and substitute with the limits.